Hey guys, this is the quadratic formula. So what we're going to go over is we're going to go over how to get a trinomial into the form ax squared plus bx plus c equals 0, and then to find 1, 2, or no values of x for that equation. Okay, so this is a means besides factoring or besides the square root method to find the values of x when you have a trinomial. And a trinomial means there are three terms: first term, second term, third term, set equal to 0. That's important. Okay. So the general quadratic equation is of the form ax squared plus bx plus c equals 0. And then we're going to plug those values into the quadratic formula. The quadratic formula is always the same. And what we've done is we've taken this and we've changed it, we've solved it for x. Okay, so you take this, solve it for x, and what you end up with is x is equal to the quantity negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay. The quadratic formula can be used to solve any quadratic equation. So if you don't like factoring, you can always go straight to the quadratic formula. If it doesn't factor, go to the quadratic formula to find an answer that's probably not going to be a whole number. Okay, so the first step of solving equations using the quadratic formula is to set the equation equal to 0 and put it in descending order. So it should always be x squared and then the x value and then the constant. Okay, step 2 would be to substitute. So after you've set the equation, you find the values for a, b, and c and substitute them into the quadratic formula. Then we'll just simplify the quadratic formula as much as we can. That is the hardest part. So that is where most of the mistakes happen. You will usually get two answers. And if, remember we went over imaginary numbers or complex numbers, you'll get two answers because here's a plus sign and a minus sign. So eventually, while simplifying, you'll separate that into negative b plus the square root of b squared minus 4ac, and then negative b minus the square root of b squared minus 4ac. And we use imaginary numbers or complex numbers when there's a negative number under a radical. So at that point, we'll be using the term I, and the answer will become imaginary. But you have practiced that. So number 2 says, we're not doing the quadratic formula for 2, 3, 4, 5, and 6. We're just identifying a, b, and c. So we'll just do step 1. We won't do step 2, we won't substitute, but we'll just find a, b, and c, okay? Step 1 says, set the equation equal to 0. This one's already set equal to 0, and make sure it's in, set the equation equal to 0, make sure the equation is in descending order. So it is equal to 0, and it is in descending order because we have x squared, x, and then the constant. Or x to the second power, x to the first power, x to the 0 power, right? Because x squared, regular x is just x time, like x to the first power, which is just x times itself, but only once. So it just is itself. And then anything to the 0 power is 1. 1 times that constant leaves us with a constant. So that's another way to think about it, is it's x squared, x to the first, x to the second, x to the first, x to the 0. So this is already in descending order. A is just 6. B is a negative 5 because it was a negative 5x. And then C is a positive 9. You don't include the x's, of course. Here we have negative 3x squared plus 24x equals negative 17. First step is to set equal to 0. So it's currently set equal to negative 17. We want to move that 17 to the other side of the equal sign by doing the opposite. So if it's a negative 17 or minus 17, we add 17 to this side. Anything we do to this side, we have to do to the other side. So we'll add 17. And what we end up with is negative 3x squared plus 24x plus 17 equals negative 17 plus 17 is 0 equals 0. Good. I put the 17 over here because, again, we want it in descending order. So I could say 17 minus 3x squared plus 24x equals 0, but then I would have to move the 17 back here. So I just immediately left the 17 in the back. Okay. If that is our answer, or if that's our equation set equal to 0, then A is negative 3, B is positive 24, and C is a positive 17. We move the negative 17 over by making it positive. C is positive 17. Similar problem here, number 4, x squared plus 53 equals negative 16x. We're going to add 16x to both sides. Good. So this will become, and this time we'll do it the other way. So it would be 16x plus x squared plus 53 equals negative 16x plus 16x is 0. And then remember, we need it in descending order. So we'll move the x squared right here. 16 is between them because that's x to the first, right? X to the second, x to the first, and then the constant. Good. Now that is correctly in descending order. And our a, there's nothing in front of the x squared. That means our a is just 1x squared. Our b is a positive 16, and our c is a positive 53. I'm going to pause this and make sure I have paper. Based on how much room I'm taking up, I'm going to run out of paper. Here we have x squared minus 16x equals 0. That is set equal to 0, and that is in descending order. So now we just say a is, remember, 1. If there's no number in front of the x squared, but the x squared exists. There's a negative 16 instead in front of the x, but there's no c. How many constants are there? There are 0 constants. Okay, so if you're missing an x squared, or you're missing an x, or you're missing a constant, it's going to be the number 0. If it's there, but there's no number in front of it, it's going to be a 1. So this is 1x squared, but there are 0 constants. 1x squared, but 0 constants. Here we have x squared plus 1. So that's going to be a is 1, b is 0, c is 1. You see the difference? There is an x squared, so it's 1, but there is no x, so it's 0 x's, and then there is a constant. You just copy the constant down. Good. All right, moving on to using a, b, and c in the quadratic formula. So now we're going to go through steps 1, step 2, and step 3. Okay. X squared plus 3x minus 40 equals 0. We want to make sure it is set equal to 0 and put in descending order, which it is. Now let's identify a, b, and c. A is 1. B is a positive 3, and C is a negative 40. Good. Now we're going to use the quadratic formula. I'm going to write it down right here. X equals negative B plus or minus the square root of B squared minus 4 times A times C. Got it? All over 2 times A. All right. Now we're going to put the 3 in here and here. And we're going to put the 1 here and here. And we are going to put the C, or the negative 40, right there. Good. So x equals negative, right? So that negative was part of the quadratic equation, but now we want b. So it's going to be a negative 3 plus or minus. So this is where we get the 2 answers, one positive and one negative square root. And then we have b squared. Remember, b is 3. I'm just going to put it in parentheses just to be careful. Squared minus 4. 4 is from the quadratic equation times a. A was just 1 times c, which was negative 40. All of that is going to be divided by 2 times a, which was just 1. Now we simplify, okay? I'm gonna run out of room. All right. I'm gonna copy it down right here so that it's easier to simplify. X equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times a negative 40 divided by 2 times 1. Or you can put it in parentheses so that, if you prefer that, not so that. All right. Negative parentheses 3 is just a negative 3 plus or minus. 3 squared is 9, so I'm going to go ahead and change that to 9. Negative 4 times 1 is a negative 4. times negative 40. I don't want to go too fast, but you're welcome to go faster. 2 times 1 is just 2. Okay. Next thing I'm going to do is I'm going to multiply negative 4 times a negative 40. So it's negative 3 plus or minus the square root of 9. Negative 4 times negative 40. All right. 4 times 4 is 16, right? So negative 4 times negative 40. It's going to be a positive 160 because a negative times a negative becomes a positive. 4 times 4 is 16. And then the 0 is carried. So instead of minus 4 times negative 40, we're going to say plus 160 over 2. So that's negative 3 plus or minus the square root of 9 plus 160 is just going to be 169. All of that over 2. So it's not just the radical divided by 2, it's everything. Check to see if that's a perfect square. The square root of 169 is 13. Yay! X is negative 3 plus or minus 13, not 16, over 2. Good. So we got rid of the radical, but well done. Not but. Now, the important thing is that there is a plus and a minus. That means we're going to switch it into 2 different equations, okay? Because the next step is, if possible, to combine like terms in the top before you divide by 2. So we can combine them, but we don't know what to do with a plus minus. We separate it. 2 equations. Negative 3 plus 13 divided by 2. Negative 13 minus, negative 3 minus 13 divided by 2. That is just a 3. Good. All right. Negative 3 plus 13 is just going to be a positive 10 because it's 13 minus 3, 10 over 2. This one, negative 3 minus 13, we're combining them and we get 16, but they were both negative, so it's negative 16 divided by 2. 10 divided by 2 is 5. Negative 16 divided by 2 is a negative 8. So here we got x is 5 and x is negative 8. That does imply that we could have factored it, but if you didn't want to factor it, you can use the quadratic formula. Our answer is x is a positive 5 and x is a negative 8. All right, 8, 9, 10, 11, 12, 13, 14. We're just going to do some examples. Good. Let's find A, B, and C. A is, well, first, make sure it's in descending order and set equal to 0, which it is. A is 1, B is a positive 8, C is a positive 16. Now let's immediately set it up elsewhere, right? So this will be x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Remember we said our a is 1, our b was 8, and our c was 16. X equals negative b, which is a negative 8, plus or minus the square root of b squared, which is 8 squared minus 4 times a times c. If a is 1, you don't have to write it there, but you can. All right, let's simplify. X equals negative 8 plus or minus the square root. So you're always doing under the radical first for the quadratic formula. 8 squared is 64. Negative 4 times 1 is a negative 4 times 16. And then 2 times 1 is just 2. So x equals negative 8 because that hasn't changed. Plus or minus the square root of 64 minus 4 times 16. 64. And let's multiply negative 4 times 16. It's negative 64. Divided by 2. Okay? So we substituted. We simplified 8 squared to 64. We simplified -4 times 1 times 16 to -64. 2 times 1 is just 2. The square root of 64 minus 64 is just the square root of 0, right? Because 64 minus 64 is 0. The square root of 0 is 0. So now we have x equals -8 plus or minus 0 divided by 2. Again, you have a plus and a minus. So you could say x equals -8 plus 0 over 2. X equals -8 minus 0 over 2. However, adding 0 and subtracting 0 are the same, right? If that becomes 0, then we see that we just have one answer, -8 divided by 2, right? So x is -8 divided by 2, which is -4. In this case, we only had one answer. X is -4. Then if you put in that -4, -4 times, or sorry, -4 times -4 plus 8 times -4 plus 16, that should equal 0. -4 squared is -4 times -4, which is just 16. And then 8 times -4 is -32. So it'll be 16 minus 32 plus 16. The 16 and the 16 are a positive 32, and then a positive 32 minus 32 is 0. So that will equal 0. So you can always check each of your answers. For number 7, we would have checked both the answers we got. You can put in 5 and make sure it equals 0. Put in -8 to the original one and make sure it's equal to 0. All right, number 9. Number 9 says x squared plus 18x plus 58 equals 0. Again, it's set equal to 0 and it's in descending order. A is 1, B is 18, and C is 58. The weird 8. Good. All right. X equals -b plus or minus the square root of b squared minus 4ac over 2 times a. And let's substitute those in, right? We said a is 1, b is 18, and c is 58. X equals -18 plus or minus the square root of 18 squared minus 4 times 1 times 58 over 2 times 1. Now we're just going to simplify, okay? X equals -18 plus or minus the square root of what is 18 squared? 324. The square root of 324. -4 times 1 is just -4 times 58. I can't really tell what that number is. So we have 324 minus 4 times 58 all over 2 times 1 is just 2. X is -18 plus or minus the square root of 324 minus 4 times 58. -4 times 58 is a -232. So now that's 324 minus 232 divided by 2, right? Let's work under the radical. X equals -18 plus or minus 324 minus 232 is 92. So the square root of 92 divided by 2. Okay. Is 92 a perfect square? It is not. So now before we do separated them into two, into plus and minus, we want to make sure we can't simplify 92. Do we remember how to simplify square roots? To simplify square roots, what we want to do is take the square root. I'll do it up here. Take the square root of 92. Think of every perfect square below 92, right? So 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, I think. 8 times 8 is 64. We can probably stop there. 9 times 9 is 81, but we are not going to be able to divide 92 by 64 or really 49. But now you want to take 92 and divide it by each perfect square to see if you can pull out any of the perfect squares, thereby simplifying 92. 92 divided by 49. No. 92 divided by 36. No. 92 divided by 25. No. Nope, just did 16. I don't think we're going to be able to divide it by 9, right? So can we divide it by 4? Ooh, you can. So the square root of 92 becomes the square root of 4 times 23. The square root of 4 we know is 2, right? So that becomes 2 square root 23. You can check your answer by saying what is 2 times the square root of 23 and what is the square root of 92. Good. I know I started at the bottom or at the biggest number and the answer was the smallest number. You can start at the smallest number, but I like to start at the biggest number because you want the biggest perfect square you can pull out, right? Okay. So that now replaces the square root of 92. The square root of 92 now becomes 2 times the square root of 23. Now we have x equals negative 18 plus or minus 2 square root 23 over 2. Good. We've simplified that as much as we can. We should combine like terms, but there are no like terms because negative 18 doesn't have square root 23 multiplied with it, does it? It does not. So we cannot combine any like terms. We can now, before we separate it into 2, we can look at dividing the 2 parts by 2, okay? Negative 18 divided by 2 is going to be negative 9. 2 square root 23 divided by 2 is going to be square root 23. Okay, so I couldn't combine the negative 18 and the 2 square root 23, but I could divide negative 18 by 2, and I could divide 2 square root of 23 by 2, thereby giving me negative 18 divided by 2 is negative 9. 2 divided by 2 is 1. 1 square root of 23 is the same as square root of 23. So now, final step is just saying that x is negative 9 plus square root 23. And x is also negative 9 plus square root 23. Good? All right. X squared minus 10x plus 50 equals 0. That means we have a equals 1. B is negative 10 and C is a positive 50. Good. So we're going to say A is 1, B is a negative 10, C is 50. What's our quadratic equation? X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Let's substitute them in. Negative negative 10. See that? It was a negative here, and then b is an actual negative number. So it's minus a negative 10. B squared is going to be negative 10 squared minus 4. A is just 1, and C is 50. Divided by 2A, right? So here is where my parentheses helped. Negative 10 is just a positive 10. Now, use parentheses when you're getting the square, because negative 10 squared and parentheses negative 10 squared give you a different answer, okay? Always use parentheses when you're substituting in for a variable. So parentheses negative 10 squared gives us 100. So plus or minus the square root of 100 minus 4 times 1 is 4 times 50 over, oops, I said 2a, but I meant 2 times 1, right? 2 times 1 is just 2. X equals 10 plus or minus the square root of 100. Negative 4 times 50 is going to be minus 200. Good. X equals 10 plus or minus the square root of 100 minus 200 is a negative 100 over 2. Now, again, remember that sometimes your answer will be a imaginary number. When is your answer going to be, excuse me, when is your answer going to be an imaginary number? When your answer is going to be an imaginary number when you have a negative 1 under the radical. So when we solve the square root of negative 100 using imaginary numbers, the square root of negative 100 is the same as the square root of negative 1 times 100, right? The square root of negative 1 is I, and the square root of 100 is 10. Or negative 1 becomes I, and then we just have square root of 100. We know that the square root of 100 is 10, so it's 10I. This always becomes this. And that's how we don't just quit after the square root of a negative number, because that's always going to be an error in your calculator. It's a non-real number. The square root of 100 is 10. And then the square root of negative 1 is I. And the I always goes behind the number. Good. So now we have X equals 10 plus or minus 10I over 2. Good. Now let's see if we get, so we simplified under the radical. We got it out of the radical. We have 10 plus 10I, 10 minus 10I. Those are not like terms. So now we're just going to move on to dividing by 2. Take each part and divide by 2. 10 divided by 2 is 5. So have a plus and a minus. 10I divided by 2 is 5I. So now we have X is 5 plus 5I. X is 5 minus 5I. Good. Okay. Number 11 is 6x squared plus 6x plus 1 equals 0. So that means A is 6, B is 6, C is 1. A is 6, B is 6, C is 1. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Let's substitute those in. So it's a negative B, but B is 6. So negative 6 plus or minus the square root of 6 squared minus 4 times 6 times 1. divided by 2 times 6. First time a hasn't been 1, right? X is -6 plus or minus the square root of 6, or sorry, 6 squared is 36. -4 times a +6 is 24. Minus 24 times 1 is just going to be -24 over 12. X equals -6 plus or minus 36 minus 24 is 12. So we have -6 plus or minus the square root of 12 over 12. Again, we're first going to simplify under the radical. We have square root of 12, and we want to think of how many perfect squares we can pull out of 12. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, right? 16 is too big. 12 divided by 9 is not going to give us a whole number. 12 divided by 4 is going to give us 3. So square root of 12 becomes the square root of 4 times the square root of 3. The square root of 4 is just 2. So 2 square root of 3. Again, you can check that in your calculator. The square root of 12 is that. 2 times the square root of 3 is that same number. Come back down here with what we learned and say x is -6 plus or minus 2 square root 6, 3 divided by 12. Good. These are not like terms, so we cannot combine them. So now we're going to move on to dividing by 12. 6 divided by 12. Previous to this, we had we only had 2 down here, and we had a number, even numbers up here that could be divided by 2. That's not the case with this one. -6 divided by 12, all we can do is simplify it, okay, into its prime factorization. -6 is a negative, let's just say a -1 times 3 times 2, right? Plus or minus 2 square root 3. Why am I doing this? Because 12 is 3 times 2 times 2, right? Those are the prime factorizations of 12. 3 times 2 is 6. 6 times 2 is 12. Now, I can say, right, that -6 divided by 12, let's split it into 2. All right, I'm going to split it into 2. It'll be easier. -6 twelfths plus or minus 2 square root 3 divided by 12. Good. Now I'm going to do the prime factorization of -6. The prime factorization of -6 is -1 times 3 times 2, right? The prime factorization of 12 is 3 times 2 times 2. If I was to make a factor tree of 12, it would be 6 times 2. 6 becomes 3 times 2. So the prime factorization of 12 is 3 times 2 times 2. -6, I factored out the -1 and it was just 6. 6 is just 3 times 2. Good. Now what can I cancel out? Those cancel and these cancel, and -6 divided by 12 just becomes -1/2. Good. Plus or minus 2 square root of 3, and we already know the prime factorization of 12 is 3 times 2 times 2. We can now factor out one of the 2's, and we get plus or minus square root of 3 on the top, and then 3 times 2 is 6. Okay, so now our final answer for number 11 is -1/2. Oh, sorry, x equals -1/2 plus the square root of 3 over 6, and x equals -1/2 minus square root of 3 over 6. All right, 3 more examples of this. Here we have number 12. What is A, what is B, and what is C? Well, first, let's set it equal to 0. So we're going to add 1 on both sides. It becomes 2x squared plus 12x plus 1 equals 0. Means A is 2, B is 12, C is 1. We said A is 2, B is 12, C is 1. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Negative B is a negative 12. B squared is going to be 12 squared minus 4. A is 2, so 4 times 2, and then C is 1 times 1. 2 times A is going to be 2 times 2. Negative 12 plus or minus the square root of 12 squared is 144. Negative 4 times 2 is a negative 8, times 1 is negative 8. 2 times 2 is 4. Good. X equals negative 12 plus or minus 144 minus 8 is 136. Positive though. Divided by 4. Now take that number under the radical. Make sure you can't simplify it. The square root of 136. What can we simplify that to? Can we divide it by 4? Can we divide it by 9? Can we divide it by 16? Can we divide it by 25, 36, 49, 64, 81, 100, right? So 136 divided by 81, 136 divided by 136 divided by 64, 49, 36, no. 25, no. 16, close. 9, 4. It's always the last one. All right, the square root of 136 becomes the square root of 4 times the square root of 34. Square root of 4 becomes 2. So it's the square root of 136 becomes 2 square root 34. Let's replace that. Good. Can't combine those like terms, so let's divide by 2. 12. Oh, sorry, this was 4. Whew. Negative 12 divided by 4 is a negative 3, right? But over here, 2 divided by 4 is just 1/2. 2 divided by 4. 4 is just 2 times 2, and then we'll cancel one of the 2's. So we just have the 1 and one of the 2's on the bottom. So X is negative 3 plus or minus the square root of 34 over 2. Make sure you do not put the 2 over all of it, right? Because that negative 3 was because we already divided negative 12 by positive 4. Okay, so the 2 is just over the second term, the last term. Good. All right, number 13, negative 8x plus 41 equals negative x squared. I'm going to move the x squared over. I always want to have my leading term positive, so don't move those 2 over here. X squared minus 8x plus 41 equals 0. That means A is 1, B is -8, and C is +41. A is 1, B is -8, C is 41. X equals -b plus or minus the square root of b squared minus 4ac 2a. Negative b is just a -8 plus or minus the square root of b squared is -8 squared minus 4 times 1 times 41 all over 2 times 1. So x equals a minus, or sorry, a -8 is just a +8 plus or minus. 8 squared is 64, so -8 times -8 is a +64. -4 times 41 is -164. And then 2 times 1 is just 2. X equals 8 plus or minus the square root of 64 minus 164 is just going to be -100. We saw that before. All of that over 2. We saw that the square root of -100 is 10i, right? Because -100 becomes -1 and 100. -1 becomes I. 100 becomes 10, and it's just 10i. Good. Divided by 2. Now we can't combine 8 and 10i, so we'll divide them both by 2. X equals 8 divided by 2 is 4. 10i divided by 2 is 5i. So we have x equals 4 plus 5i and x equals 4 minus 5i. Last one. 4x squared equals 3x minus 1. Again, I want my leading term positive, so I'm going to move this side. Okay, so that I still have a positive a. 4x squared minus 3x plus 1 equals 0. You will get the same answers if you move the 4x here and we say 0 equals -4x plus 3x minus 1, because you'll see that that's the inverse, right? The inverse would be 0 equals -4x squared plus 3x minus 1. And so you kind of have the opposite. That's a negative. Here it's a positive. Here it's a positive. There it's a negative. Here it's a negative. There it's a positive. I like my leading term to be positive, so I'm going to use this one. A is 4. B is -3. C is 1. But you will get the correct answer if you use that one too. We'll give you the same answer. All right, so we've got x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. -3 plus or minus the square root of -3 squared minus 4 times 4 times 1 divided by 2 times 4, right? Because a is 4. Now let's simplify. X equals -3 is a +3 plus or minus. -3 squared is 9. -4 times a -4 is a +16. 2 times 4 is 8. So we have x equals 3 plus or minus the square root of 16 and 9 is 25 over 8. The square root of 25 is just 5. So we have 3 plus or minus 5 over 8. x equals 3 plus 5 over 8. X equals 3 minus 5 over 8. Why did I separate it before I combine like terms? Sorry. Why did I separate the positive and the negative before just combining like terms? Because I can't combine them because one, I have to combine them with addition, the other I have to combine them with subtraction. 3 plus 5 over 8 is just 8 over 8. 8 divided by 8 is 1. Here we have 3 minus 5 is a negative 2 over 8. And that would be negative 1/4, right? Because that would be negative 2, 2 times 2 times 2, negative 1 times 2 over 2 times 2 times 2. Negative 1 divided by 2 times 2. So x is 1 or x is negative 1/4. Good. All right, in these last examples, if you have just an x squared term and a constant, so there's no middle term, there's no b, you can use the square root property to solve an equation. Step 1, isolate the squared term by itself on one side of the equation. Step 2, take the square root of both sides. And always use the plus or minus on the side with the constant, as you should be getting 2 answers. So simplify your radical as needed. So square root property just says, if that's a perfect square and that's a perfect square, you can just take the square root of both. Remember to use a plus and a minus. So x squared equals 121. What I'm going to do is take the square root of x squared will give me x, and the square root of that side will give me the answer, but there's going to be a positive and a negative of that answer. X is 11, but 11 and negative 11. Why? Because negative 11 gives me the same answer squared as positive 11. So that's why you need the plus and the minus. X squared equals 23. Again, take the square root of x squared and the square root of the other side, because there's no x on it. The square root of x squared is just x. 23. Can you simplify that at all? First of all, it's just plus or minus 23. 23. Can I divide that by 4? No. Can I divide it by 9? No. Can I divide it by 16? No. Can I divide it by 25? No. Good. So it's just x is square root of 23. X is negative square root of 23. Same thing. So we're trying to, if we don't have a middle term, we don't have a b, we can isolate the x squared by moving the constant over to the other side. It was a positive 36, so I'm going to subtract 36 and subtract 36 and get x squared equals negative 36. And then I'm going to take the square root of both sides. The square root of x squared is just x equals plus or minus square root of negative 36. Okay. Remember the square root, or sorry, the plus or the minus just means you have 2 answers right at the very end. So don't worry about the plus or the minus, worry about under the radical. Is there any way to simplify negative 36? Yes. Negative 36 is the same as becomes 36 and negative 1, right? The square root of 36 becomes 6. The square root of negative 1 becomes I. So the square root of negative 36 is just 6I. So we're going to say x equals plus 6I, sorry, plus or minus 6I, which means x is 6I, x is negative 6I. Good. Here we want x squared alone, the constant over here, so we're going to add 19. X squared equals 19. take the square root, add the plus or the minus. Good. The square root of 19, can I divide it by 4? Can I divide it by 9? Can I divide it by 16? No, right? So we just say x is the square root of 19. X is negative square root 19. Number 20 says 5x plus 75 equals 0. Now, this is not x squared alone, right? So what we need to do is move the 75, and you don't have to use this to solve it. You don't have to use the square root property. You can use the quadratic formula, or you can factor it, okay? But first, let's move 75 over. This is the square root formula. 5 squared equals negative 75. This isn't x squared alone, so we're going to need to divide by 5, right? X squared equals negative 75 divided by 5 is a negative 25. So we have x squared equals negative 25. What we need to do is now take the square root. X is plus or minus square root of negative 25. Remember, the square root of negative 25 is 5i, because that is the square root of 25 times the square root of negative 1. The square root of negative 1 is the I. The square root of 25 is the 5. But we have those plus and minus, so we say x is 5i, x is negative 5i. Good. All right, guys, that is it. Oh, it's not, because negative 75 divided by 5 is not 25. I was hoping we could divide it by 3. It's just rushing number 20. Number 20 is wrong. Number 20 is wrong. Let me begin again. 5x squared plus 75 is 0. We want to use the square root method. You do not need to use the square root method. You could also just say that this is A is 5, B is 0, C is 75, and use the quadratic formula. That will totally work. But if we, in fact, want to use the square root method just to practice, what we need to do is we need to move that 75. 5x squared equals negative 75. Now divide by 3 and see if you can do it correctly. Divide by 5. I'm still wishing it was 3. Divide by 5. We get x squared equals negative 75 divided by 5 is negative 15. Good. Okay. Now take the square root of both sides. When you're taking the square root, make sure you use the plus and the minus. The square root of x squared is just x. Negative 15 is 15 and negative 1. 15 we can't simplify because we can't divide it by 4 and we can't divide it by 9. So it'll just be I square root 15, but put the I in front. Good. So that becomes I square root 15. So x equals plus or minus I square root 15. So x is in fact I square root 15. X is minus I square root 15. All right, guys, and that is for real, all of it. Good. Because this was the answer if it had been 3. Just made up the problem there because I liked it better. All right, thank you guys for watching, and I hope you have a great day. Bye.